Hello and welcome one and all. Today we will build a Great Expectations suite. This is a request I've received based on the previous Great Expectation video from a few of the viewers. So here we go. Great Expectation is a Python library that helps data engineers develop reliable data pipelines with built-in validations at each step. By defining clear expectations for our data, it ensures that the data meets those data quality expectations, making it reliable and easier to work with. We have covered this library in the past. We built a custom set of data quality tests and executed them against our dataset. We'll leverage the validations or expectations as they're referred to by the Great Expectation library. I will leave the link for the previous video in the description below. In short, this library aims to fix data quality issues in our dataset. With that out of the way, let's dive in and build a Great Expectations suite. We have created a new folder called Great Expectations. In this folder, we have our dataset inside the data folder. We'll use the CLI to develop this, so let's launch a terminal or a command prompt. Before proceeding, make sure you have this library installed. We can use the pip package manager to install it. As it happened, this library is already installed on my machine. We create a new Great Expectation project, or suite as it's called, with the init command. So we provide Great Expectations init. This creates a blank project with all the necessary components. We have various files and folders in a folder called Great Expectations. We will provide Y to proceed and create this. We have the Great Expectations folder created, and inside this we have the required files and folders. The next step is to create a connection to our dataset, so this suite can connect to our data. We run the following command: Great Expectation data source new. For now, we can connect to files or our database. We will provide one for the files. Here we decide on the processing engine. We can select Pandas or PySpark. We will supply one for Pandas. This data source connection requires the path to our data file. So we'll go ahead and copy and paste the file path. This will launch a Jupyter notebook. This has a pre-written code in it. Here we can define a connection to our data source, and it will be added to our project. We start by importing the libraries. We specify the data source name. We can update the data source name to our liking. I will leave it as default. For file-based data sources, we create a YAML-based configuration. We can update it to only pick Excel files. Now we can test the data source connection to make sure everything is in order. It has picked up our Excel file, so this looks good. Now we can save and persist the configuration to the YAML file in our project. Configurations are saved, and we can close this notebook. I'll go ahead and close this kernel with Ctrl+C key on the keyboard. Our Great Expectation project is in place, and we have a data source connection established to our dataset. Now we can create a Great Expectation suite. So we'll provide Great Expectation suite new. Here we need to select how we want to create this suite. 1 for manually, 2 for interactively, or 3 automatically. We will go for the third option. In case there are multiple files, which file would we like to use? We will enter 1 for the first file. We need to provide the name of the suite. We can provide any name, preferably related to our dataset. So I'll provide ADV for AdventureWorks and suite. The following will save the suite in a JSON file, and we will accept this with Y and proceed. This action will open a new Jupyter notebook where we can define the configuration for our new suite. Here we have the data source name. It'll be the same name that we provided in the previous steps. This includes the connector and the data file name. Let's go ahead and execute this cell. This will read our data file into a Great Expectation data frame upon completion. This is our data set as a data frame. The data frame is called validator. We can either go with the default assistant or define our own test cases. Let's go ahead and print out the data frame to preview the data. We will define our own test cases as the digital assistant runs into error. I will remove this block of code and add in a few more cells for test cases. If you recall from the previous session, we read in our data and defined the test cases or expectations manually. For example, the first one was expected row count, then we have column check, null check. This is followed by the data type check, and finally the column value checks. We will implement these tests in our suite. On our data frame, which is called the validator, we'll call a built-in function row count and provide the number of row counts we think exist in this dataset or should exist in this dataset. This is a success as the same number of rows exist in the dataset. Next, we want to check if the following columns exist in our dataset. First is the product category. This is a success. We perform the same test on the sales column. Let's say these columns are required for analysis, so these must exist in this dataset. Next, we check if the sales territory is always populated with values. This is a null test. We can also test the data type for a column. We provide the column and define the data type for it. We need this column to be an integer. We can check if the column values fall within a range with a between function. We supply the column and the min and the max values. Lastly, we check if the mean of a column falls between a range. Now we save and review our expectation suite. This will save and apply our expectations on the dataset. We can see the data quality test function we applied in the configuration. All the data quality tests we applied are listed here. Upon completion, this opens up a documentation page where we can see the results of the data quality test we ran. This starts with an overview. We have 7 expectations and their results. This begins with expected number of rows, and following this we have a couple of tests on order quantity. We are checking the data type and its values should be in a provided range. Next, we have the sales column. It is a required column, therefore it should exist in the dataset. Then we check whether the standard cost median is in the provided range, and this is true. Product category is a required column, and sales territory column must not contain null values. Both of these are true. So this is a Great Expectations suite, and this was a walkthrough of how we can create a Great Expectations suite and execute it against a given dataset. If we need to modify the suite to include more tests, we can run the following command. It will bring up a Jupyter notebook where we can update or add in new expectations. This is all on Great Expectations for now. I hope you enjoyed the session. Like, share, and subscribe. Take care, and I'll see you in the next video.